Hi everybody, and welcome to the second video on vectors. In this video, I just want to get a little more practice with them and show you a few more things you can do with them, ultimately with the goal of becoming more comfortable with them. So I'll show you a little bit more of the cute things you can do with them, but mainly this is sort of just dipping our toes a little further in the water than we did last time. So there are three things I'm going to show you how to do. First, I will show you how to sort a vector. Then I will teach you how to find something inside of one. So maybe you have a list of integers and you want to know, is the number 45 in there? I don't know why, but is the number 15 in there? Whatever. So writing code that will search a vector for something you are looking for. And then lastly, how do you throw something out of there? Maybe you don't want that 45 in there or that 15 in there, whatever. Once you find where it is, you can throw it out of there if you want to. So these three examples are what the video will show you. So first, let me start with sorting. So what do I mean by sorting? What I mean is that the list by itself, the vector as constructed, could be in all sorts of jumbled order. In particular, if the user is giving you these numbers, there's no reason the user has to enter things in order unless you really force them to. So how could you take a jumbled list and rearrange the list so that the numbers go from smallest to largest? Well, I should say that you guys actually have the tools to do that. It's a pretty sophisticated thing to do at this point in the course. By the end of the course, you should be able to do it in maybe an hour to write code that does that. But that's pretty sophisticated. But let me just point out, you do have the tools to do it. It is, or it can be done with some clever usage of loops and if statements. But be that as it may, somebody else has already done it, so we will just take it. If you do an include algorithm at the top, this single command will sort a vector from smallest to biggest. So you say sort, and then whatever the vector's name is, so my vec, in this case, dot begin, empty parenthesis, and then my vec dot end, empty parenthesis. So just to show you how that works, I've created already a vector and I've put it in jumbled order. So 1, 10, 5, 7, 3. Okay, so if I run this code, here's my for loop that prints a vector. What it should print out to me is 1, 10, 5, 7, 3, because that is what the vector is right now. Suppose, though, that after I display that to you the first time, I say, hey, I didn't actually want that in jumbled order, so I'm going to sort using this syntax from over here, begin.end. Okay. So now what I want to do is print the vector again. Okay, so what's happening here? Here the vector is created by me. Here I print that vector for the first time. Then I sort the vector using that sort command. Then I print the vector the second time. So let's just see the difference between the first and second printings. The first time the vector prints, it prints the vector as created, 1, 10, 5, 7, 3. But then I told the code to sort from smallest to biggest, and it did. So now 1 is in position 0, 3 is in position 1, etc. Okay, so why might this be useful? Well, there are lots of reasons why, but the example that comes to mind for me is that if I wanted to drop homework scores for you, which I do at the end of the semester, I drop the lowest ones, then what might be useful is to just take your jumbled list of homework scores, sort them, and then I know exactly where the lowest scores are. And once I know exactly where they are, I can skip them pretty easily. So that's one use of this. Okay, so if you can sort things from smallest to biggest, you can of course go backwards if you want to. You can also sort things from biggest to smallest. How would you accomplish that? Well, the easiest way to accomplish that is to sort from smallest to biggest. That's what this line of code does. And then you can use a command called reverse. So what does reverse do? Reverse just takes a list and reverses it. Okay, it does exactly what you think it does. So let me just come back up here. Right here, if instead of saying sort, if instead I said reverse, let's just see what happens here. So the original list, right, was 1, 10, 5, 7, 3. And now, after I reverse and print, it's 3, 7, 5, 10, 1. Right? So it just literally reversed the entries. What was last is now first. What was second to last is now second, etc. Okay. So if you wanted to sort your list from biggest to smallest, you can first sort from smallest to biggest. So that will write things as 1, 3, 5, 7, 10. And then just reverse that. That will then put the 10 first, the 7 next, etc. And that's what happened. Okay. So before moving on, let me point out that in the past, students have thought that this reverse command on its own will sort from smallest to biggest. But as we just saw, that's not the case. It will not take a jumbled list and list things from biggest to smallest, that reverse command. It just reverses entries. So if your list was jumbled before, it will still be jumbled after doing reverse. It will just be listed in the opposite order. So you have to do sort first to get from smallest to biggest, and then reverse to get from biggest to smallest. So these two lines of code in tandem here do that for you. Okay, so that's the end of our example 1 in our little list here, right? So sorting, we now know how to do that. Okay, so now let's talk about searching inside of a vector. So suppose you have an integer vector, my vector, whatever, you want to know if 1 is in there. Okay, how would you do that? Well, here's some sample code. Let me just walk you through it. You can create a function that's kind of like the find function in for strings, where first of all you create a variable x, and what x is going to do for you is record the first instance of the number 1 that it comes across. Okay, so this integer x is a positional number. So if this number 1 is in position 5, then x will tell you that 5. It will say, hey, I found a 1, and I found it at position 5. So recall that's exactly what that string finder function does if you tell it to start searching at position 0. It gives you a position back, and that position is precisely where you found what you were looking for, the first instance of it, right? And that value is -1 if you never find what you're looking for. So by setting x equal to -1, I'm defaulting to the idea that I won't find what I'm looking for. Okay, so then if I want to find 1 inside of that list, I can just search the vector entry by entry. So start at position 0, then go to position 1, etc., all the way to the end of the vector. And if what you are currently looking at is 1, so what does this mean? Right? Remember, this I is position inside the vector. It's not the entry itself, right? So this right here, that myVec bracket I, that is the value at position I, the entry at position I. So if the entry at position I is 1, then I'm going to record that position. Okay, so I could be 5, could be 8, whatever. So I'm recording a box number here, that x is now I, this position where I found a 1. And then, this is a new command here. We haven't seen this yet. But if you think about what's happening here, this loop, it's starting at the beginning of the list, and it's going all the way until the end. But if all we care about is finding a 1 in there, and we just want to know where the first one occurs, then it actually doesn't matter how many 1s there are. There could be billions of them. As soon as we find a single 1, we want that loop to stop. We don't care if the loop keeps going because we got a single hit, and that's good enough for us. So this command here, this break, what this does is if you ever encounter that in the code, it just stops whatever loop it's inside of. Okay, so let me say that again. If we ever go inside of this if block, and we will if we find a 1, if we ever go inside of here, we're going to command the loop to break, which just means break out of this loop. So, hey loop, I know you want to keep going until you reach the end of the vector, but I'm forcing you to stop right now because I found what I wanted. Once that loop is done, then I can just ask, was x equal to -1 or not? If x is still -1, if x is not equal to -1, that must mean I found a hit, and I'll tell you where it occurred. Otherwise, I must not have gotten a hit, right? X must still be -1, and so I can say 1 did not appear in your list. So let me go back up here, and let me get rid of all of this. And, okay, I have this code already typed just to save time here. Whoa, okay. So here's all of that code from the slide. Let me just copy and paste it in. Okay, so here's the original vector here, my vec. There is an entry of 1, and it occurs first. So if this code here does what I claim it does, it should report to us that a 1 exists, and furthermore, it should tell us that entry occurs at position 0. So in other words, x starts as -1. When we start this for loop here, right, we start at the beginning of the vector at position 0, and we keep going to the end. If we ever encounter an entry of 1, then x records the position where that happened, okay? X doesn't become 1 itself, it becomes the position where 1 occurs, and then we break out of that loop. And then afterwards we can report where we found something, if indeed we did. So what should happen here is that we get a hit, and we get that hit at position 0. So let's run this and see if that happens. 1 appeared in your list, it tells me. The first occurrence was at position 0, it tells me. That's good. That's what it was supposed to do. Okay, so now let's just toy with this a little bit. Let me just put some more 1s in there. Right now there are 3 1s. So it could potentially find 1s at any spot. Let's see what it does. At any of the 3 spots. It tells me 1 appeared in your list. The first occurrence was at position 0. Okay, so in other words, this code down here, this loop, it didn't even see these other 1s. Why didn't it see them? Because of this break command. The first time it enters this if block, and that first time is right at the start, okay, because we get a 1 so quickly. The first time you enter this if block, the loop breaks, the loop stops. So that's how you record the first instance of a 1. Okay, let me now change this 1 to like an 8. Let's run this again and see what it thinks. Now, it should tell us the first occurrence was at position 2, and it does. Okay, what if these 1s weren't 1s, but they were something else? It should tell us it didn't find a 1. 1 didn't appear in your list. Okay, how did it know that? Well, because x was initialized to -1, the only way that x changes is if you enter this if block here. You enter that if block only if you encounter a 1, and we did not. Okay, so this entire loop ran. We never got a hit. We never went in here. Therefore, when the loop was done, x was still -1, and we went into this else block. Okay, so there's nothing special about the number 1. If you want to search for something else, like 16, I don't know, you can do that too. You would just tweak the code like this. If what I'm currently looking at is 16, go ahead and record that for me. And then, of course, you would want to change this stuff down here, right, so that the output matches what you were looking for. But anyway, there's nothing special about searching for the number 1. 16 appeared in your list, and its first occurrence was at position 3. Indeed. Okay, thank you. So that works just fine, right? So you can take this little schematic here and tweak it to your needs if you need to search. Okay, finally, how do you erase something from a vector that you don't like? So in other words, maybe you don't like all of those 1s inside of your vector. How would you get rid of them? Okay, the way you would do it is like this. The command is simply myvec.erase, and then you do myvec.begin plus, for some reason, okay, I don't know why, I, where I is the position where you want that entry deleted from. Okay, so you can't just tell it like, hey, delete a 7. You have to tell it where that 7 is. So you have to tell it, oh, that 7 is in box 13 or whatever. So you have to give it a position that you want it to erase, not the entry at that position. So let me just let me clear out a lot of this. Clear this out. Okay. So now I'm back to my original vector, which I've changed, but still 5 entries. I'm still going to print it for you, but now I'm going to do something like this. myvec.erase. Let's do myvec.begin. Yeah, okay. Let's erase the guy at position 2. The guy at position 2 is 11. So what should happen here is we erase the 11. Let's see if that happens. So it prints the original vector, and then it prints the new one after that erase command, and what do you know? The 11 is gone. It's gone because we told the code to erase the entry at position 2, and the entry at position 2 was 11. So the new vector has size 4, no longer size 5. Okay, so we can now do 3 things, as promised, right? So hopefully you now acknowledge we can do these 3 things. We can sort vectors, we can search for things inside of them if we feel like it, and we can erase things if we feel like it. So let's now put all these together in one program that does this. You don't like the number 13. It's unlucky, right? You're one of those people that when you build a hotel, you don't have a floor 13. You go straight from 12 to 14, whatever. Okay. So let's write a program that deletes all instances of 13 from a list. Okay. So let me come back here and let me just get rid of all this for now. So let me just create, let's get rid of a bunch of this. Okay. So what I'm going to do next, this is a cute little trick that we haven't talked about yet. Suppose you want to let the user create a vector, which I want to do because I don't want to have to hard code everything inside the program. I just want to enter like 10, 7, 8, whatever. And then I want those entries put inside the vector. What you can do is something like this. As long as the user is giving me a number. Okay, we've seen this loop structure before a couple of times. So this loop will run as long as the user is entering integers. The easiest way to let a user create a vector for you rather than you having to type the numbers is like this. As long as they are giving you a number, put that number inside of the list. So recall what this pushback function does. It takes whatever I just gave you, that input, and throws it onto the end of the list. Okay, so far I haven't done anything like this prompt right here, but let me just run this and show you how this works. So I'm going to enter some numbers like 7, 5, 4, 7, 6, whatever, and then I'm done. And then I ask the code to print what it thinks that vector is, and it prints 7, 5, 4, 7, 6, what I typed, right? And the reason it knew all that is because I was just throwing each of those entries into the vector at the end using this pushback function. Okay, so this little snippet of code here lets the user create the vector for you. So the user can type whatever they want, and as long as they are giving numbers, you create a vector. Okay, so what I'm going to do now is write a program that deletes all instances of 13 from that vector. Okay, so now I'm going to have to search for 13s. So I suppose what I want is this code somehow. Okay. Maybe I'll come down here. Okay, so far, what's happened? The user has given us a vector. I will print that back to them. I'll show them what they entered. Okay, now down here, what we should do is search for 13s, because we're supposed to get rid of them, aren't we? So this code right here will find the first instance of a 13 for me. Okay. So surely what I need to do is find all instances of 13 though, don't I? So what I'm going to do is I'm going to take this basic structure here. I'm going to get rid of this. What I want to do is search the vector for 13s. So if what I'm currently looking at is a 13, I should do something, shouldn't I? What I should do is erase, and I should erase at that position. So let me now come here, and I don't want the loop to stop. I want to keep going until I've seen all the 13s. Okay, so what's that syntax here? Okay, my vec.erase, my vec.begin, and I want to erase where I'm looking. Okay, and then I want to print the vector again just to show you it works. Okay, so let me just recap what's happening here. The user is going to give us a bunch of numbers, and we're going to let them create the vector itself, so I don't have to type everything inside the code, right? I don't have to sit here and type like my vec.0 is 10. I don't want to have to type that over and over again, so I'm just going to let myself throw these numbers in here via the command window down here. Then I'm going to print that to the screen. And then what I'm going to do is I'm going to march through the vector box by box, entry by entry. I'm going to ask myself, do I currently see a 13 or not? If I do currently see a 13, I'm going to tell the computer to erase the entry at that position. That will then wipe out that 13. And then I'm going to print the result to the screen. So let's see if this works or not. So I'm going to do like 13, 5, 7, 13, 6, 4, 13, and I'm done. What gets printed back to me? What gets printed in the end, right? So first, here's all my input, right? It prints the original vector to me here. So that's this first print for loop where? Right here, where I tell it to print the loop for me. Okay. Then I do this erasing stuff. Then I tell it to print the loop, print the vector again. And notice it prints 5664. The 13s are gone. Okay, that's nice. So it seems like it's working. Let me try again. 13, 13, 14, 13, 13, 15. Done. Okay, well, let's see. Here's the vector as I entered it. And then notice down here, what it should print is a 14, 15. It's not though, is it? There's still 13s here. Why is that? It erased 2 of the 13s, but not all 4 of them. What has happened here? Well, it's actually pretty subtle, okay? So I'm going to let you think about it. I'm going to show you the fix, okay? And the fix involves something I told you not to do previously, but, you know, every time you tell somebody not to do it, there are like situations in which you should do it. You know, it's like when I tell my toddler, like, hey, don't do that. If she were older and smarter, she could always think of a situation in which she should, right? So anyway, up here in my erase for loop, I told you that in general you should never mess with this I variable inside the loop because it's sort of confusing to do that. Here's where I changes, right here. Okay, but I'm going to mess with that I variable right here. I'm going to decrease it by 1. Surprisingly enough, that will fix this issue I just showed you. And let me show you that it fixes it. Okay, so 13, 13, 14, 13, 13, 15. Done. What? Oh no, infinite loop. Stop. Okay, that was my only change, right? So let's take that out. So 13, 13, 14, 15, 13, 13, whatever I said before. Done. Okay. Okay, so this must have made the thing infinite. Well, let's try again. It really shouldn't have, because it's inside this if statement. So you're only backtracking if you ever enter that if statement. 13, 15. Oh, okay. I don't know why it just did that infinite loop before. Okay. So somebody in class can tell me if they notice anything wrong I did here. Okay, now it seems to be working. Let me try to remember that original thing I did. So what was it? 13, 13, 15, 13, 13, 14, then I'm done. Okay, who knows? Anyway, so as I originally said, okay, putting an I minus minus there actually fixes that issue. So now notice all the 13s are gone. So in the interest of time here, and just as a challenge for you, I'll let you think about why putting that one line of code there fixes this issue. But notice what's happening here is that the original code couldn't handle multiple 13s in a row. So this was the code here, some sequence like this is what broke the original code. But now this new code is handling it just fine. So I'll let you think about why this is now taking care of that. Okay, so now, okay, yeah, so no more slides. Now I claim that we are comfortable with these three things. You can sort a vector from biggest to smallest and from smallest to biggest, either way, right? You can search inside of a vector for something you're looking for, like a 1 or a 13, and you can erase entries from a specific spot. Okay, that's it.